In the fourth part of the session today, talking about problem solving and thoughts and how they are happening in the brain. Are you ready for a problem to solve? I'm going to give you a problem. Be ready. You are supposed to report your response as soon as you can in your in the chat space. Let's start. This is the problem. So we have a kind of a starting point. We want to get to this goal, and you need to kind of do it with the least number of moves, and you can just report your moves as something like red to 2. We need to just bring red to 2, and then you can see how you can go. And in each move, you can just move one of these globes or one of these kind of small objects to be able to go to the next move. So provide us with your answer and see how fast you can find the solution with the minimum numbers of moves. The number is, you are not supposed to give just a number. You just need to do something like what Mikhail has done for just saying that, okay, blue to 1, red to how many moves. Handon is saying that four moves is not just about the number of moves, it's about just reporting your moves. Now, let's see the actual response. In 3 moves, so you can just basically go blue to 3, and then red to 2, and then green to basically 2, and the next move would be getting to the goal. Yeah, that's true. It is 4 moves. At the kind of the last, you need to have another last move to be able to do it. So it is not a really complex problem to solve. How being an expert is going to change the way that you can solve those problems. This is another interesting question in terms of, okay, if I get to be an expert, and if I do, this is what they call Tower of London questions, and there are some other versions with something like Tower of Hanoi, and there are some other versions for that as well. So we can discuss about that. But that is a quite interesting process, how people solve problem. And one of the major things that people realize that people usually do is just thinking about what are the potential options that they have. So they try to represent different options that they have. Let's think that you have this situation. You have 2 options from here. So you can basically put the right ball to the middle, or right ball to the kind of left bar. So you basically have 2 major moves. And then for each of these moves, you have 2 other moves that you can make. And sometimes you can just have one other option. So for example, for this one, you can just bring the gray one to the middle. So there is no other option. So you just have one option. And then if you move from this, then you can see that overall, there are limited numbers of moves that you can do in total. And this is what we call a problem representational space, or sometimes we can tell it solution representation space. So you have a space that representing the entire solutions that you might have for the entire task. And people are able to make a representation, sometimes just 1 move, or 2 moves, or 3 moves, or different levels of these moves. And it might be also interesting for you if you just start to kind of make this map yourself to see how many options you have for these problems. So people realize that people are using these maps and how they move from one part to the other. There are different studies in terms of how people use these representational space to be able to solve the problem. But the role of inner language is critical. So you realize that it's critical for you to be able to use your language to be able to solve the problem. Okay, I'm going to ask you another question. So I'm going to ask you to solve another problem. And for this problem, I need you to have a paper. So you need to bring a paper like this kind of white paper. And you need to have a pen. And you also need to have your phone to be able to solve the problem. Okay? And how you solve the problem, I will give you the question. You will write the question or make the figure on your paper. And then as soon as you solve the problem, you just take a photo from this, your solution, and you post your solution inside the group that we have in Telegram. So you would start to kind of share your solution inside the group, and then you will see who is going to send the first solution or the first solutions to the group. So that is the way that we communicate to see how many people would be able to kind of share their questions. So realize that you use your phone, you take photo, you share it in the Telegram group that we have, and we will see who is going to respond as fast as possible. This is the problem. You have 9 dots. You are going to use just 4 straight lines without lifting the pencil. So you are supposed not to lift your pencil from the paper, and then try to connect all those 9 dots with 4 straight lines without lifting up the pencil. Space to be able to solve the problem. And meanwhile, I should tell you that, how much kind of language you have used to solve this problem. The question would be, those who are experts in these problems and those who are not expert, what is the role of expertise in solving these problems? And if you start to kind of extend your... Hello, Zahra. How was your experience? To be able to solve this problem. If you kind of try several times to solve this problem, or if you do different exercises of these problems, what will be the difference? So, and I will discuss about that later on. And then one of the Ashkan, what was your experience? Let me just see if it's working or not. Okay, just change to the pen. Okay, so we call that Wisconsin card sorting task. It's basically a simple matching stimuli task, which is simple. So you have a card, and you have 4 sample cards in front of you. So you are given another card, and you are told to just match this card with one of those cards above, and then you would receive a feedback whether your matching is correct or not. So the process is, we usually start with color. The first rule is color. So if you are given this card and you put it under these 2 or these 3, that would be wrong. But if you put it under this, we say that it is correct. So over the time with try and error, you will realize that, okay, the rule is color. So I need to, whatever card that I'm going to receive, I'm just going to match that based on the color, okay? And as soon as you give us... That is an interesting experience in terms of observing different kind of modules of cognitive processing. Just come in and try to contribute to the process, and how you might be able to differentiate their roles. And as you kind of extend your understanding about all these different modules, you would start to even enjoy more in terms of how these players are playing their role in this interesting cognitive process. So I'm just inviting people to think about how these 2 problems are quite different from each other, or are they the same for them in terms of how they try to solve. And there are some other kind of problems. I'm going to kind of present some of the other problems. But it's quite interesting to start to observe yourself when you try to solve a problem and see how you do the process. And when you are successful, what are the things that are happening before finding the solution? Is there anything that are happening before the solution that is going to be helpful or predictive about whether you are going to be successful to predict or to find the response or not. Okay, so that's a really kind of interesting experience and process. And let's move forward for these questions and the answer that as others have mentioned, that this is the answer that we have. We need to think out of the box, not just connecting the dots. We need to think about going out of that space to be able to solve the problem. Then the question would be, those who are experts in these problems and those who are not expert, what is the role of expertise in solving these problems? And if you start to kind of extend your expertise, what does it mean at the end of the day in terms of what would be the difference when you extend your expertise to be able to solve this problem? If you kind of try several times to solve this problem, or if you do different exercises with these problems, what will be the difference? So, and I will discuss about that later on. And then one of the concepts that are going to be critically important in terms of the problem solving is something that we call flexibility. For measuring flexibility, we use a task that is called Wisconsin card sorting task. It's basically a simple matching a stimuli task, which is simple. So you have a card, and you have 4 sample cards in front of you. So you are given another card, and you are told to just match this card with one of those cards above, and then you would receive a feedback whether your matching is correct or not. So the process is, we usually start with color. The first rule is color. So if you are given this card and you put it under these 2 or these 3, that would be wrong. But if you put it under this, we say that it is correct. So over the time with try and error, you will realize that, okay, the rule is color. So I need to, whatever card that I'm going to receive, I'm just going to match that based on the color, okay? And as soon as you give us, I think it was 4, so something like, I can double check the instruction for Wisconsin card sorting task. But as soon as you start to, or it might be 10, 10 times, then you do that 10 times in a row in terms of doing that in the correct way. Then we change from color to number, and then from color per number to shape. So just after 10 correct responses, we change the response to number. And then if you match the card to the color, then it would be wrong. So for the first few responses, you would be confused because you feel that, okay, I found the rule, but now it seems that the rule is changed. And then you would start to think about, okay, how can I find the new rule? There are people who just stick to the previous rule that they found, and they cannot change their strategy. And this is called perseverance. It's called perseverance. And it is one of the kind of hallmarks of frontal cortex lesions. Some of the patients who have frontal cortex lesions, they have perseverance. So they just stick to the previous rule, and they are not flexible enough to change that really fast. And then what we do, we basically do that two times. So we change rules from color, numbers, kind of shape, and then color, number, shape. And people are supposed, they have limited numbers of kind of cards, and we can see if they can fill all these 6 rounds of kind of rule change, and whether they are, how much they're flexible in terms of changing their strategy as soon as they realize their strategy is different. And this is something that is called one of the kind of the tasks for measuring how your brain is flexible to change the rules in kind of in a really fast process. So these are the other tasks that are measuring how people are flexible. And it seems that flexibility is one of the major kind of important factors in terms of how we might be able to solve problems. When we talk about flexibility, we need to think about other important functions that are important for what we call executive control. And executive control is probably one of the central core of problem solving. We discussed about the role of central executive function in terms of changing the voluntary top-down attention, but there are other components to the executive control that are critically important. So first of all, we discussed about flexibility, which is, as we discussed, how we can change the direction of attention or other cognitive processes from one aspect to the other aspect and seeing other aspects that might be important as well. And then it seems that goal setting, defining what is the goal and finding the goal and try to kind of define a specific target that we need to get into is going to be one of the major functions of this executive control. And then how we can get to the point, but how we can get to the goal is what we call planning. And planning is another aspect of executive control. And then we have inhibitory inhibiting interferences, which is when we have a specific goal and we have defined, okay, 1 step, 2 step, 3 step to get to the point, there is always some other kind of interferences that would just distract us from the main goal. And how we suppress them is called inhibiting interferences. So we try to suppress those rows that are not getting us to the goal that we had. And then we need to monitor whether we are getting to the goal or not. So monitoring the progress towards the goal, and then adjustment. If we feel that, okay, I'm going to this pathway, but it seems that it's just getting out of the goal, I need to adjust my way back to the target that I had, which is called adjustment. And then being able to maintain the information that are related to goal into the working memory for a long period of time is called maintenance. So all these aspects together is making what we call executive control. And this executive control is the significant hallmark of the process that we use for problem solving. Okay, so this is the core for problem solving. How this executive control is being processed in the brain is something I'm going to discuss in the next steps. How this is going to be happening in the brain. And we'll discuss about the networks that are involved in this executive control. And we discussed before about what we call kind of executive control network, which is involved with frontal-parietal areas and how these parts are interacting with each other. I will discuss about this specific network in the next parts. But there are some other functions that are critically important for the process of problem solving. And there are some other models other than executive function, which is critically important. I'm not sure we have enough time today to go to the depths of those cognitive functions, but one of the most important parts is what we call mental imagery. So mental imagery is another important part of the problem solving. And with mental imagery, we specify the problem, we list possible solution, and we imagine outcomes. Okay? So these parts are supposed to be happening in the mental imagery process. And what we do with the mental imagery, we start to do what we call prospective memory. So we start to imagine different things. We start to think about those kind of imaginations, and based on those imaginations, we make goals and we make memories for those goals. Okay, this is the goal. I'm making a memory. I'm going to get to that point. And this is the path that I design in my mental imagery to get to that goal. And I start to make a memory from this process and this kind of steps to get to that goal. But these memories are about things that have not happened so far. So we are talking about things that are going to happen in the future. So we call this process prospective memory. So I need to use my mental imagery to be able to imagine all the solutions that I have. I'm sure that when we talk about mental imagery, it's also in kind of the inner talk definitely contribute to this process, but it's also a sort of visual part. So we have both visual and language processing involved to do the mental imagery. And then from these mental imaginations, we start to make memories. And those memories are going to be prospective. So we make a plan, we make a goal, we define the path to get to that goal, and these pieces are going to be recorded in our memory as something that is going to happen in the future. So it's a future memory, not the memory about something that has happened before. So it's about what is going to happen in the future. And we call this process future episodic thinking, or EFT. And this is another way of solving problems, what we call but future episodic thinking. So we start to think about, okay, what is the problem? What are the solutions that I have for the problem in my mental imagination? And the solutions should be imaginary in details. And they are supposed to be episodic. So it's something like the events that are happening in front of you. So when we talk something episodic, it's about the events that are happening. So events that are happening around you. And you start to think about them and select the best options. And then based on the options that you have, you start to make memories from them. Okay, so these two pieces are going to work together. So without having those memories or memory parts, besides what we have in terms of the executive control that we discussed before, we cannot solve the problems. And there are specific, let's say, interventions. I might even have, as you can see here, this is a part, we call it a slide model that we developed here. And it is in the page of 210 in the package that we call Brain Gym Neurocognitive Empowerment for Addiction Treatment. So this is a package that we design. You can see that we are discussing about decision making and problem solving. This is decision 12, and then we discuss about different sort of problems and how they can solve this problem with these strategies. And we work with patients and with the students and with different groups of kind of target populations in terms of how to specify their problems, how to use different, and then even those kind of the things like kind of Tower of London, we kind of include them in these trainings and some other kind of other scenarios, and we train people, and then they have some homework. This is the homework part. So they are supposed to do these homeworks, and based on that, we go for another session discussing about some other aspects of these basically trainings. But technically what you see here is how we train people with these strategies in terms of their recovery, their brain training, and how they can use these strategies. So this is not just about, let's say, just a cognitive neuroscience. It's also about how we use these cognitive neuroscience trainings to be able to help patients or to help people who are supposed to use these strategies in their life. Even there are, let's say, executives in industry or those who are supposed to use their brain in the most kind of efficient way. For all those people, these kind of scenarios are going to be critically important. I'm not going to go to the details of these kind of, let's say, scenarios and strategies, but this is the way that we basically train people. As you can see, these are really comprehensive packages. And we designed these packages, I mean, all these cartoons and see that you can see here, they are designed from scratch, in-house. And yeah, I'm not going to go to the details about that, but that's the kind of the package that right now I have a trial going on with this package, which is called the NEAT trial. You can find more details about the NEAT trial in the body page. And as you can see here, in this package, we start from, let's say, attention, and then flexible attention, and then interoception, and then emotional attention, inhibitory control. So we're building up different kind of trainings for these people to and then emotional memory, declarative memory, executive memory, future memory, and then we get to the decision. So we feel that if you want to talk about decision making and problem solving, we need to start from some building blocks and help people to learn about these building blocks, and then they can get to the next steps. Okay. And that is the end of this part of the class. And in the next part, I'm going to talk about the effect of training and how the training is working in this process.